So we'll change gears a little bit now and talk a little bit about nutrients. And I was asked to talk about environmental impacts of, on the nutrient uptake, focusing on soybean. And so talk a little bit about how the plants take up nutrients and how the factors that could affect the rate of nutrients or the efficiency of our fertilizer in these situations. And as is the soybean school, we'll go back to the basics and see a little bit about the uptake of these different elements. This is a table showing the amount of nutrients, the main nutrients that soybean will take it up to produce 50 bushels to the acre. And the amount of nutrients that will be in the grain and the amount of the same nutrients that will be in the residues. And so part of the nutrients that the plant is taking up will be exported with the grain, part can go back to the soil, recycling for the next period of time. But as you can see in this table, nitrogen is the element that the soybean will require in highest amount, and is even highest than the amount of nitrogen that we need for corn to produce 150 bushel. It's a lot of nitrogen for soybean. The good thing is that we have the microorganisms, we have the nodules that can provide us with the nitrogen, and thankfully we don't need to apply them in most of the cases. But how these nutrients are taken up during the crop cycle? If you look at this, in this first chart is the biomass accumulation. And so you can see since the planting up to R8, how looks like the plant growing during the cycle. The green part is the biomass, the stems, leaves, and pods, and the other part, I don't know what color is that, but it's the grain. It's like a mustard, but it's the grain part. And so you can see that when you are going to R3, R4, we start to have the accumulation of biomass in the grain. And let's see how the nutrient goes during this time. When you look at the nitrogen and you look at the general uptake curve, is exactly the same way that the biomass. It means that the plant is growing more and the plant requires more nitrogen. What is different here is that the amount of nitrogen in the biomass will decrease when the plant goes to the maturation, because nitrogen will be transferred from the leaves to the grain. And so we have this shape. And you can see that it's different. Here is just grain, the biomass is starting, and here we have some transfer of nitrogen from the biomass. Look at this for phosphorus. We have exactly the same shape of the general uptake curve, and again, we have a lot of transfer of phosphorus from the leaves to the grain when we are forming and filling up the grain of soybean. For potassium, we have something similar. We have some, we lose some potassium in the end of the cycle. This is very common. We have, especially if you have rain, we can wash out some potassium from the leaves. It's very common to see. It's kind of weird, but it's the way that works for potassium. It's a very free nutrient inside the plant. Calcium, magnesium, and sulfur. We can see for calcium, almost the calcium will be in the biomass, and we don't have a lot of transfer of calcium to the grain. The same as for magnesium. Magnesium, you can see a little bit different, the shape of the curve, but is not that much. For sulfur, is very similar to nitrogen. It increases when the plant grows, and after we have some transfer to the grain. For boron, manganese, and copper, you can see again that the shape is very similar to the biomass uptake. For some of these elements, like boron and manganese, we have the plant take it up to put the boron, for example, directly in the grain, and for copper, we have the transfer from the leaves to the grain in the end of the season. But and here we still have for zinc and iron, we have some different shapes. But when we put all of these together, when I stack all these curves in the same graph, what you can see there is is not that different from the biomass accumulation. The biomass accumulation is a black line over here, and all the nutrients, they are accumulated almost in the same way. It's completely different for corn. If you do the same graphs for corn, we have an early season uptake of nitrogen. We have magnesium early season, and we have zinc. And this is the reason that these three nutrients are very important when we are in V4, V6, and we sometimes need to apply, especially nitrogen, of course. But for soybeans, more like the plant is growing, I know that I need more nutrient. The plant is just speeding up. This is the time that I will have more uptake. It's more regular with the biomass accumulation, okay? So this is the way that these nutrients are accumulated. But what are the sources for these nutrients? From where are they coming from? When you think about what is a good fertilization program, for all these nutrients except for nitrogen, all of them are coming from the soil. And so when I think about what is a good program for my fertilization, if you have a good soil, that we can have a lot of nutrients in the soil, probably the plant can grow with the nutrients that I have stored in the soil. I have my savings account in the soil, and I'm using the nutrients from that savings account. If I have a soil with low fertility, I need to provide more because the soil cannot provide everything. And so when you think about a good fertilization program, is the amount that is required for the yield level that we have, for example, 50 bushels or 70 bushels of soybean, and what's the amount of nutrients that is required for the biomass plus the grain for 70 bushels, and how much I have in the soil. And the difference will be my fertilization program. This is the way that it works. But how can we know how much I have in the soil? Of course, the soil testing is the way for us to quantify how much nutrient we have available. This is some data that we have, that we collect in the last 3 or 4 years. Many of these extension agents in this room, they help us with samples for this. And we collect samples in all counties with a big representative acreage of agriculture. We end up collecting samples in 83 counties, about 500 samples in representative agricultural fields that our agents choose for us. And so we got all these samples and we did the big averages for the state. And you can see here for phosphorus that we have for the ag counties, more than 75% of the fields, they do not require phosphorus. We could go for at least 2 or 3 crops in a row without applying phosphorus because we have high or very high fertility in phosphorus. And some fields we still have a fair amount of fertilizer that are recommended. When we move to potassium, it's a little bit different. Potassium, we have more than 75% of our fields that require potassium every year, that require at least 60 pounds in average of potassium. What's the reason for these two big nutrients to be very different? Phosphorus, the plant exports much less phosphorus. And if you look, you don't remember the numbers from the first table, but for phosphorus it's 55 pounds, and for potassium is 150, 3 times more. And so I'm exporting with the grain. This is just the amount in the grain. I'm exporting much more potassium every year. And there is another problem. Phosphorus I accumulate in the soil. I can't accumulate too much potassium. And so I don't have very high potassium fields. You can see here, only 7% of the samples are very high. Because we have sandy soils that cannot hold potassium, we have leaching, we have some other process, but especially the export of potassium by grain that will make us to replenish potassium very often, okay? For micronutrients, we have less than 10% of our fields that require the micros that the NCDA are testing, copper, manganese, and zinc. We have specific situation, and here in Blacklands we know about the importance of copper, for example. But in general, for the state, we have very few fields that would require the application of those micros. How it is important? Well, all of you faced this problem the last 2 years of the prices of fertilizers. And here you can see the price for DAP, UAN, and muriate of potash. And in 2021, in the end of 2021, 22 had very high prices for these things. And it's a little better now, but we are not back to the levels of prices that we have in 2020, unfortunately. And so you are facing very, we have these pressures of the nutrients, your fertilization program, to be a big chunk of your costs. And these are some numbers of our Ag Economics department at NC State, that for corn is about 33%, 34% of your cost is fertilizer and lime. And for soybean is about 1/4 of your costs. And so if you can save some money doing a management where we define exactly when you need to apply those nutrients, we can save some dollars in your fertilizer program. So, when you use NCDA soil testing services, we report for you the results in indexes of phosphorus and potassium. So I will show you some results about this and how the environmental situation can change the response of plants to this range. What we consider at NCDA is that when you have less than 50 indexes for phosphorus or potassium, we have low fertility, and we should apply fertilizer because you have response of the plant to the fertilization. And this is the soybean school, and my plant here is a corn. Sorry about that. All of us are doing the same thing this morning. I know it's hard to just draw a soybean plant than a corn one. So, and if you have more than 50, we are good to go. We do not expect a response to fertilization. Okay? So, I will show you some results that we have in our trials using that approach that Rod told you early in the morning. When we have response, a significant response, or statistical significance of the response to our treatments. And here I'm showing 3 different sites that we are working for multiple years. Some years here are soybean, some others are corn because of the rotation. But I'm showing results of this site where in Tidewater Research Station that the index is very low, it's 26. And we are applying rates of phosphorus from 0 to 150 pounds every year. And this is the response that we have. When I have a star here, it means that we had a response, a significant response to the fertilization. You can see that always we have response because we start with a very low phosphorus. This is Coastal Plain in Pinal Belt Research Station. Again, we start with 17. We should be at 50. And we apply different rates and we increase the response of plants. The same in the Piedmont. We start with 5. We need 50. And you can see that we have the response of plants. And here are some pictures. You can see this is the 0. And this is when we apply fertilizer in a soil with a low index. You can see the difference. They are completely different. The yield levels are completely different. And you should apply phosphorus in this situation. But we have some other situations where we start with a higher phosphorus index. And here we are going from 43 up to 170. And remember, 50 is our number that we should stop to apply. None of them we had response. Different counties, different years, applying different rates of phosphorus. You can see none of them we have response to this fertilization. Why? Because we had high fertility. Remember, a good fertilization program is I need to apply if I have low fertility. And this is just another example. You can see some other trials that we had here, applying, in this case, phosphorus and potassium together. And again, we didn't have response because we start with higher phosphorus levels. This is in the black land. This is 2020. And you can see that we didn't have a difference because we start with a higher phosphorus index. We apply 50 pounds or 0, and we have no response in yield. The thing that Rod told you is that the probability that we have for some response, and we calculate the probability for these different trials, and you can see that from our calculations, if you have less than 25, we have 100% of chance of response to fertilization. And if you have more than 45, it drops to 0. If you are about 30, 35, your chances are about 50. It's like flip a coin. You may apply fertilizer, no response, or may apply fertilizer, have response. When you have response in this range, this is the environmental things. If you have a year that you have a lot of moisture, it's hard for the plant to take it up phosphorus. And this is when we have response in this range. If you have a year that is very dry, the plant cannot take it up the nutrient because it don't have water. This is the year that a higher phosphorus level will respond better. And this is the environmental thing that is important. Okay? And so these are, I put all the trials. Rod told you that we need to repeat these trials in different regions, different situations, and so we can have more chance to understand how it works and when it works. And we can see here, we always have response to phosphorus and we are below 30. And we never have response in all these trials in 25 sites when we have more than 30. And we have some sites yielding more than 60 bushels to the acre. And so they are not only low or average yielding sites. When you look at the recommendations that we have from NCDA, if you have very low phosphorus, we start with our recommendation of 150 pounds, and we keep applying about 70 pounds in this region, in this range, that we don't have a response. And this is the safest thing that we have in our recommendations. This is for those years that we yield more than the average. Okay? This is for those years that we have too much moisture, cool soils, or dry soils. This is our protective fertilization. And also, this is when we are applying fertilizer just to replenish the exports that we have. And so this is the way that we protected the yields, applying more than the response of the plants. Probably in a good year, if you have an index of 40, do not apply, nothing happens. Okay? Except if it's dry, too wet, or some odd situation that will impair. For potassium, I will go faster. Rod is telling me that I don't have too much time. For potassium, we have the same situation. Okay? In sites where we start with low potassium, we have sites that respond, some sites that we do not. Always when we have higher potassium, we have no response. And you can see here, again, below 30, we have a response to potassium. After index 30, we don't have a response. We don't have a very high potassium fields because we cannot accumulate potassium in the soil. Remember that. It's different from phosphorus. And when you look at our recommendations, recommendations for potassium, they are different. The protective fertilization is a huge range from 30 up to 80. We are still recommending potassium at index 75. Why is that? Because the exports of potassium are higher. And so I need to replenish that. And so again, this is, and you have leaching in some soils also. And so again, we have this range where you are recommending potassium, not because you have response, because you need to keep your fertility in a good range. This is the potassium deficiency. And this is a soil that we were in that range from 30 to 50. And you can see there is deficiency. While the soil were dry. After our rain, it just vanished by itself. And so this is the reason that we have those protective recommendations. Nitrogen. We try nitrogen working with ratio for in some of these sites. We apply nitrogen at planting or at flowering for soybean. We didn't see response. We did see the reduction of the nodulation in some of these sites when we apply nitrogen, because the microorganisms start to get lazy. If you have nitrogen in the soil, the plant doesn't need that, and so. But we have some situations like this. This is one producer from Virginia that they had pine trees in the previous year, and they have a huge problem with nitrogen deficiency because you don't have a lot of microorganisms in the soil. In this situation, maybe nitrogen would be an option in the toolbox. I do not recommend nitrogen in normal situations, but maybe in this one, we should think about that. But by far, the worst problem that we have in North Carolina is pH. Low pH is the most common problem in our soil test reports. 36% of our mineral soils require lime, okay? And it's based in more than 500,000 samples. In this situation, look at nitrogen deficiency in a soil of pH 4.5. Nodules in some spots where we probably have a little bit of more organic matter, no nodules when the pH were very, very low. Another situation that maybe nitrogen should be in your toolbox. Another problem that we have, now the low pH, now do you over-apply lime or apply ashes or something that will increase too much the pH? Another common problem in North Carolina, we have manganese deficiency, because when we increase the pH, the manganese availability will decrease. And so this is another thing that is related to the environment that we should think. For micronutrients, we try sulfur and micros, and in situations where the amount of these nutrients were good in the soil and we didn't see increasing yields in those situations where the soil report were not asking for those nutrients. And Andrea told you about the diagnostic program that we have. This is a wonderful program that we have in North Carolina where we got samples from good and bad spots, soil samples, tissue samples, and we can run both at the same time at the NCDA, and we can try to figure out what the problems are. And it's an amazing program that we have. Please talk with your agent to use this if needed. So sometimes some of you tell me that I don't like to, I always tell do not apply fertilizer. I love to apply fertilizer. My plate is NPK lime. I just want to tell you, you need to apply fertilizer when you need them. Okay? And so don't search me on the, yeah. Okay, thank you very much.